Hi there, welcome to AP Environmental Science lecture on chapter 14. This is part one today. This chapter, Environmental Health and Toxicology. Let's begin. The central case in your chapter talks about a chemical called BPA or bisphenol A. All right. Bisphenol A is a common chemical that was used, and it is still being used. It's in metal can coatings, dental sealants. It's in actually the ink that puts store receipts. And basically when you grab a store receipt, it's in the ink on the store receipt. It's found in plastics of different kinds. It hardens the plastic. So basically, it's a chemical that is around us. We eat it sometimes. We ingest it. How do we ingest it? Well, if it's found in plastic and our water is in the plastic, and you drink from it, it'll enter the plastic. It'll leach into the plastic, and you'll ingest it. How else do we take it in our bodies? Well, if you eat canned food, or if you have a canned food item in a recipe, the lining of the cans has BPA in it, and that leaches into the food. Studies have been done where they've realized that people who eat canned food have very high numbers of BPA in their body. That study has occurred basically. If you eat or drink, another example, diet sodas or sodas in general, canned soda, doesn't matter if it's diet or not. Soda in general, the lining of the soda cans, BPA in it. All right. So some of your plastic water bottles that you're using, if they're plastic, a lot of them say they're BPA free. They may have another chemical in there that's substituted for BPA that is very similar to BPA. It just hasn't been tested yet, so we don't have data on it. Okay, so BPA is a chemical. This chapter is to show you that we have chemicals around us, and those chemicals around us can be harmful to us. How is BPA harmful to us? Well, BPA is linked to many, many ailments, many diseases. They're not saying, and they don't have proof that it causes all these problems, but they know it is associated and linked to all of these issues here. Why is it, or how is it associated to them? Well, BPA is a chemical that mimics or behaves like a hormone in our bodies. And the hormone it specifically behaves like is estrogen. And the thing about hormones is what people don't know is it doesn't take a large amount of a hormone to have an effect on our bodies. It takes very minute, very small amounts of hormone to have basically large effects on us. So when we're putting a chemical in our bodies that's entering our bodies called BPA, our bodies now are tricked into thinking that this hormone is present when it isn't a hormone. Actually, it's a hormone mimic. It behaves like a hormone, and our bodies react to it. And those reactions could lead to health issues. And it's showing you all the different health issues here that it could be linked to. Now, environmental health. So this is a field. This is what this chapter is about. We're going to be looking at different things around us. So there are environmental factors and how they influence our health, our life, our quality of life. Now you'll see the term anthropogenic pop up. Man-made or man-influenced or man-created, something involving man. Anthropogenic, specifically in our chapter, we're going to be talking about anthropogenic causes for a lot of these things, which means nature can cause environmental health issues. Yes, we are going to talk about that, but we're going to mainly deal with the stuff that's man-made, what we are doing to throw things off balance. So let's define a few things. There's different kinds of hazards that are around us in the world. Physical hazards, chemical hazards, cultural, biological. So let's first talk about physical hazards. These are things that are natural disasters, ultraviolet radiation, things that are physical that are around us that can be hazardous to our health. Chemical hazards, synthetic chemicals, meaning man-made chemicals, pharmaceuticals, disinfectants, pesticides. And not only those are all man-made, natural toxins also are part of this chemical family of hazards. And these pictures showing you a sunburn here, showing you someone spraying, in this case, pesticide around their house. Biological hazards, living things, all right, or vectors, and we're going to define those in a second. So infectious agents, things that make us sick, all right, very common one, and a very common vector are mosquitoes. Well, what do mosquitoes do? Well, they carry disease, and they bite, and they basically, when they bite somebody, they're trying to take the blood from the person. They're infecting them with another organism that can cause disease. Things that cause disease are called pathogens. So The vector in this case is the disease carrier, which is the mosquito. Due to climate change, as things have gotten warmer, there's more mosquitoes, so there's more diseases like malaria. So basically, mosquitoes are a vector for the disease known as malaria. All right, that's what they do. They transfer disease from person to person. Um, these we've done many things. We've tried to kill them. We try to get rid of mosquitoes. We try to use different chemicals, different pesticides to remove them. This is showing you their belly full of blood here. Malaria kills about 3 to 400,000 people a year worldwide. Most of them are in Africa, and they die because of the disease they get, malaria, as a result of the bite. Cultural hazards. If you go to certain parts of the world, you'll notice that people behave in certain ways that you're not accustomed to. Here in Southern California, you don't see a lot of people who smoke, for example. But if you go to parts of the world like South America or Europe, you'll see people who smoke all over the place. It's part of kind of their culture. They've accepted it as part of their culture. That in itself is a problem because it can lead to many other health problems that we're going to talk about in a little bit. We also have issues with non-infectious diseases. Now, non-infectious diseases are things that are not spread from person to person. What makes us more susceptible to them? It's our DNA. Also, what we expose ourselves to in our environment and how we choose to live our lives. These diseases, they can be lessened by changing your lifestyle, smoking less, drinking less alcohol, eating better. All right, those are common ways. Most common types of things that lead to death that are non-infectious are respiratory infections. And this is influenza, pneumonia. They need to add COVID to this list of respiratory infections. And this tally just got bigger this last year in 2020 as a result of all the deaths worldwide as a result of COVID-19. So I already just mentioned it earlier, a pathogen, any disease-causing agent or organism. What I mean by agent could be a virus, and a virus is not alive technically, so it is not considered an organism. So it could be a virus or a bacteria or a type of fungus or a prokaryote, something that will make you ill. What do they generally do? For example, what does a virus do? They usually infect you and they invade your body and then they reproduce. And then you somehow expel them into the world. For example, when you cough or you sneeze, COVID-19 could be spread. If you have COVID-19, you can be spreading it that way. A lot of times viruses will spread within your body, keep you alive because they want to. A lot of viruses have evolved to keep you alive because then it allows them to spread themselves and their ability to spread more of their DNA easy that way. If they kill the host quickly, if the pathogen kills a host, then the host cannot spread the pathogen. So it's not a very good thing for a pathogen to kill their host very quickly. What have we done to fight infectious diseases? Well, here's what we've done. We've figured out a way to sterilize water. You can boil it. That's a very high energy cost. So now we figured out how to add chemicals to it, like chlorine. Our water is chlorinated, the one that we drink when we get our houses. We have sanitation. Indoor plumbing has been a good thing. People are not, there isn't fecal matter all over the place, which is causing sanitation issues and diseases spread that way. Nutritious diets is a big one. This is a huge one. Eating better will decrease a lot of diseases by increasing your ability to have a better immune system. Right now in the U.S., due to COVID, we're dealing with all kinds of stuff, such as quarantining is a big one right now. If you keep away from people, it's hard to spread disease to them. And so this is happening currently on and off in our country, around the world right now due to COVID. Now, our book went over a infectious disease breakout of Ebola. It talked about Ebola that happened in 2014. Well, Ebola kills people rather quickly, and that's a good thing for us, believe it or not. It's an evolutionary positive for you and me. Because Ebola kills people so quickly, it's difficult to spread it very far. So people die rather quickly. They can't incubate it and move it along like diseases like COVID. COVID, someone could be an incubator and not even show symptoms and spread it along. Same thing with HIV and other things of that sort. What happens to certain viruses? Well, they mutate, they change. So, our ability to protect you from them is limited over time because For example, a vaccine is only good for so long in a lot of cases. All right. So what's happening? Why are things spread so easy? Well, when COVID came about or Ebola came about, people are traveling. There's a lot of business taking place worldwide now. Things are manufactured all over the world. So it's easy to travel from point A to point B because of business. And that travel has caused pandemics basically around the world. Toxicology. So how bad is something for you, or what kind of reactions does it cause? Well, how toxic something is relates to how much of a dose you get of it, by the way, and how it reacts. So the dose and how chemical reactive it is will tell you how toxic something generally is. We generally want to know how poisonous something is because we want to know at what point is death going to be caused by this chemical. Okay, so we're going to talk about how that's calculated in our next lecture. We're going to talk about what's called a dose response curve, which deals mainly with toxicity. So indoors, health hazards that occur indoors. We're lucky we don't have a lot of radon here in in Southern California, but other parts of the country like South Dakota, they have it there. Areas that are built on uranium deposits have it within their soil. So what is radon? Well, when these rocks and this radioactive activity takes place deep in the earth, it releases a gas called radon. This gas can seep up through these rocks and through the soil and makes its way into houses. People can inhale this radon, and this is a radon testing kit that you would expose in your house and then send it off and have it tested. What they would do is radon can make its way into the house, like I said, seep through these unsealed caverns of your home and cracks in the foundation. And then over time, you can develop lung cancer. It's one of the leading causes. The other leading cause of lung cancer, excuse me, it's not the second. The other leading cause is cigarette smoke. So exposing yourself to cigarette smoke, even secondhand smoke, or radon are the two leading causes of lung cancer. Asbestos. This is a chemical that was used up until the 70s. It was an insulator. It's no longer used. Why? It's pretty bad for us. If you inhale it, it can scar the lungs and do damage to the lungs called asbestosis. Another toxin that makes its way into our homes is lead. Where does it come from? Well, a lot of old paints used to have lead in them. We do not use lead-based paints in the United States, but they're used in things that are produced overseas, for example. You may not know. Why is lead bad for us? Well, lead can mainly damage brain and nervous system activity, and all these other organs get damaged that are trying to filter it out, the liver and the kidneys and the stomach. So lead is a problem. It's a heavy metal. Heavy metals generally destroy nerves and brain primarily. That's why they're a big problem. PPDEs, these are fire retardants. What does that mean? They're chemicals that are put on electronics. I mean, you have them on your phone, you have them on your furniture, you have them on your bedding, you have them on your beds, your sofas. You're constantly surrounded by these chemicals and all the things that they're put on. Why do they use them and why are they so heavily used? Well, because the chemical industry wants them to be used. They want laws made that force producers of furniture, for example, to douse their stuff into PPDEs so that it makes them fireproof so that you won't die in case they catch fire. The sad part is, I mean, I don't know about you, but I don't have a flame near my sofa, and my sofa doesn't catch fire that often. I don't have fires that are occurring in my house all that often. So, do I need to surround myself by PPDs? No, I don't. But I am as a result of laws that are mandated and produced that force the producers of all these different things to use them so that these items are less able to catch fire. The industry, the chemical industry, wants you to use them because they're getting paid every time something is produced. Their chemicals are being purchased and used in these items. All right, so the push comes from the chemical industry to use them. Our lawmakers allow these laws to be passed because the chemical industry is giving money to the campaigns of these politicians. It's called lobbying. So the corporations lobby the politicians to pass laws that benefit the corporations. They make it look like they're benefiting me and you by creating a fire retardant, but we do not need to be exposed to fire retardants all the time. Why could this be bad for us? Well, PPDEs, just like BPA, are hormone disruptors. So they disrupt our body's chemical messengers called hormones. And like I told you earlier, it takes a small amount of hormone to cause problems. And we are constantly, when we sleep at night, our pillow was doused in PPDE. So they're entering our pores, basically, of our body. European Union, Europe is not like we are here in the United States. They do not allow a lot of these chemicals. They banned them in 2003. They are not banned in the United States. So if you buy a pillow in Europe, it's not going to have PPDEs on it. If you buy a pillow in the United States, it was doused in PPDEs. Are people in Europe having issues with their pillows catching fire? No, they're not. Their sofas catching fire? No, they're not. Are we having those problems in the US? The industry, the chemical industry, will say we're not having problems because they've doused everything with PPDEs. But that's not the case. They really want us to keep using them and buying them from them. All right, toxins. All right, so things. What is a toxin? Where do they come from? Well, they come in a lot of cases naturally. Organisms make them as self-defense mechanisms. So, for example, they'll produce them so that a snake will produce toxins so it can paralyze its prey so that it can feed. Some plants produce toxins naturally so that other things that eat them won't eat them as a result of them being poisonous. Man-made, anthropogenic, we make a lot of synthetic chemicals that are, in a lot of cases, considered toxins. This shows you right here, basically, they're all around us. Chemicals are all around us. So tens of thousands of chemicals have been manufactured for various industries. The US, we are absolutely the worst when it comes to how many chemicals we allow and how many chemicals are used. Why are we the worst? Our laws are put in place. They really protect the industry. All right. The laws that are put in place protect the corporations more than they protect you and me. We have to prove that their stuff is causing problems. They don't have to prove that it's safe. We have to prove after the fact that it's causing issues. The problem is after the fact, you might have died because of the issues or the cancer that you developed as a result of the chemical. Where do all these environmental synthetic chemicals come from? Antibiotics, detergents, solvents, perfumes, and organic substances, you name it, all kinds of things. Common one, pesticides, pesticides, pesticides. Recent studies, there's been a lot of recent studies regarding pesticides, and one common one would be Monsanto's pesticide that's used called Roundup. We had an earlier chapter where we talked about Roundup Ready crops. Roundup is now linked to cancer, basically, different kinds of cancers. It's a very commonly used pesticide. The company that owns Roundup is called Monsanto. I believe they've set aside about $10 billion to pay off the lawsuits associated with Monsanto's Roundup and its cancer-causing agents. These pesticides, we use them all over the place. They become airborne. They're in our food. They're all over the place. You have a lot of them in the Great Plains in the Midwest. Why? Because that's farm country. A lot of pesticides there. A lady by the name of Rachel Carson back in the 60s wrote a book called Silent Spring. Now, why is this book important? Well, our book, this is a environmental science class. So she was bringing light to environmental science, specifically in the form of toxic chemicals, the chemical industry. In her book in 1960, she wrote about specifically a chemical pesticide called DDT, which was used all over the place. She was connecting it to health risks. What was the issues that happened? Well, so her book was about the chemical industry and how bad it is for us. She was getting death threats. People in the chemical industry were not happy with her. She was sued. People were coming after her. Why? Because they didn't want themselves to be exposed. The chemical industry did not want people to know how unhealthy, potentially unhealthy their products were. All right. So her book led to an awareness. All right. And people started thinking more about chemicals and toxins around us. These toxins are classified carcinogens. This is one grouping. What is a carcinogen? Something that changes DNA in a way that affects proteins that damage the cell cycle. So The cell cycle is how a cell multiplies its DNA and gets ready to divide itself, and it's the life cycle of the cell. Proteins control all the steps of the life cycle. If DNA changes affecting those proteins, well, the life cycle is out of control, and uncontrollable growth could become a tumor, and that becomes cancer, right? Chemicals that are carcinogens are these PAHs, polycyclic aromatic hydrocarbons. These are the things they're found in. When you burn charred meat, they're saying has it in them. Cigarette smoke, common. They're usually aromatics, which means they have a scent to them. They have a ring, a carbon ring, right? When you're fossil fuels, when you're burning fossil fuels, so these are related to things that are burn. Cigarette smoke, charred meat, emissions, or the burning of fossil fuels. So combustion is burning stuff. Um, Problem with carcinogens is you may be exposed to them now and you may develop cancer years later. It's very hard to detect carcinogens. It is believed, your book, I remember when I was in college, my instructor told me 30% of the people on the planet are going to be dealing with cancer at some points in their lives. Your book says 2 out of every 5 Americans. All right. So when I was in college, I learned about 30% of the people on the planet are going to be dealing with cancer. According to our textbook now, about 40% of Americans, 2 out of 5 Americans, are going to be dealing with cancer at some point in their lives. It's a very high number if you really think about it. Mutagens, things that cause changes in DNA. Mutagens can be carcinogens. We just spoke about carcinogens. Most mutations, just so you know, most things that cause mutations have little or no effect. All right. Some I just said can lead to cancer. It depends on the person, but cancer could be 1 to 10 mutations in DNA. Depends on the person, depends on how your DNA is coded. I remember I've read a bunch of studies in the past that they said on average it's around 4 mutations could lead to cancer. It just depends on the person and where your DNA was and how your DNA was coded when you were born. Teratogens, things that cause birth defects, smoking and alcohol while pregnant, not a smart thing, or doing any drugs while pregnant can lead to birth defects in children. Smoking and alcohol commonly lead to a lot of mental birth defects in children. Neurotoxins, chemicals that damage brain and spinal cord, the nervous system, and the neurons of the cells that connect everything. We're going to talk about allergens. Allergens are common. Our immune system reacts to different things. Some of us are hyperimmune, which means our immune system is overactivated by certain chemicals. So allergens are when that occurs. We have an immune system response when one is not necessary. Something isn't making us, it's technically not something that should make us ill, but our immune system is reacting in a way where it's overactivating the immune system. One of the problems that people who are dying of COVID-19, when people die in the hospital, they are getting their immune system is overactivated. So this is one of the common side effects of COVID-19. So your immune system activates to fight off the virus, for example, like COVID-19. But then if your body treats it like an allergen, you have an overactive immune system as a result of COVID-19. Your body starts attacking itself when that happens. So that is one of the common problems that people are having due to COVID-19. They're getting what's called a cytokine reaction. It's like a landslide of a reaction after reaction after reaction, all immune based, and your body is literally taking itself out. That's a common way people are passing away due to COVID-19. What is your immune system made of? Your white blood cells. These are little soldiers swimming around looking for things to take out. Antibodies are chemicals that we produce. Lymph nodes store a lot of these antibodies, and a lot of these produce some of these white blood cells that we need. So these are the areas where a lot of them are produced, those white blood cells. Pathway inhibitors, another type of toxin. These block steps of biogeochemical pathways. A common one is the pathway called respiration, where we want to produce energy. Cyanide, which is a very severe poison. I believe it's one type of rat poison, but it can kill just about anything. What does it do? Well, it interferes with our pathway to produce ATP, or energy, cellular respiration. So that would lead to death if you can't make energy. Endocrine disruption or disruptors. These are things that disrupt our endocrine system. What does our endocrine system make? It makes our body's chemical messengers called hormones. Small amounts of hormones cause major changes. All right, so it doesn't take a lot of a chemical. If it's an endocrine disruptor, you don't need a lot of that chemical to have changes and problems developing. A lot of the common ones, like I said, BPA, a lot of these are estrogen mimics, and they're dealing. Common problems are fertility issues, lower sperm counts, small testicles on animals, and if it's happening to animals, I'm imagining it's happening to males and humans also. The endocrine system, they make those chemical messengers, those hormones. All right. The glands that produce them these are common ones. The pituitary, the hypothalamus, thyroid, adrenals, ovaries, testes. If you hear about these glands and if these glands are affected, they're probably being affected by an endocrine disruptor, and they're throwing off how they're naturally producing the chemicals that they need to make. All right. So this is just showing you what happens. Hormones bind to receptors, and then it triggers a response. So an endocrine disruptor has a similar binding area as a natural hormone. So it mimics or behaves like a hormone. So you now have an endocrine disruptor here in green. It's now landing on receptors and triggering a response where a response shouldn't be triggered, basically. So that's what an endocrine disruptor does. Finally, to wrap up today's lecture, phthalates. These are used as softeners in plastics. I mean, I tried joking around, but it's kind of true. If you ever have opened up one of these plastics from their packaging and you get that scent, that plastic scent, oh, you're probably smelling phthalates along with BPA, all those great scents. These are not these are not good for us. Endocrine disruptors again, linked to birth defects, cancer, sperm counts, reproductive effects. Where are they found? They're found in cosmetics commonly, and they're softeners in plastics. All right. So we are going to wrap our lecture up there today.